This video contains a PowerPoint presentation read by the speaker.
Martin Fowler famously says that any fool can write code that a computer can understand. Good programmers write code that humans can understand.
The slide title reads, Minimizing Complexity.
Being clever should never be the aim of programmers. Programmers must not aim for complex code and must not go the fancy way of achieving a certain functionality. Instead, always aim for simple and readable code. Simple code is easy to review, maintain, evolve, test, and document. There are various guidelines to writing simple code, such as following standards and design best practices. Code is simplified by making use of coding standards, such as naming, layout, and commenting conventions. There are various sources for standards. They can be adopted from specific platforms, or from external organizations, or can be built internally to meet specific needs. Regardless of whether we use internal or external standards, the important thing is to apply these standards in a consistent manner. Of course, adopting external standards makes it more likely for employees to be aware of these standards, so use external standards whenever possible. As an example, here is a link showing C# coding conventions.
The URL reads, http://msdn.microsoft.com/n-us/library/ff926074.aspx.
Following best practices during coding is essential. Best practices come in different flavors, but I will divide them into 3 categories. General practices, such as modular design and decomposition. Programming methodology-specific practices, such as solid principles of the object-oriented programming. And platform or language-specific idioms and practices, such as .NET design guidelines for exception handling, memory management, and so on. Language idioms capture solutions to language-specific problems. You can think of them as the equivalent of architecture styles and design patterns, only at the coding level. The following Pluralsight course explains object-oriented solid principles, and the following link explains some of the .NET Framework coding design guidelines.
URLs read, http://www.pluralsight.com/courses/encapsulation-solid and http://msd.microsoft.com/en-22904%208v=vs.110%29.aspx.
Change is inevitable for software. Change can be in the environment where the code runs, or due to change in requirements. Therefore, building extensible code is a key aspect of software construction. This means that code can adapt to changes with minimum impact on the overall structure and behavior. Various techniques can be used to create extensible code, such as adopting high cohesion design, maintaining low coupling between components, adopting abstraction and encapsulation, utilizing configuration files and dynamic rules, and, as much as possible, write code that is not coupled to any specific environment or infrastructure. In addition, language or platform-specific techniques could also help us write extensible code, such as the use of attributes and reflection in C#. Reuse enables productivity, cost saving, and increased quality. Reuse here refers to both writing code that is reusable and reuse code from other sources. Writing reusable code means writing components that are independent from any specific system or subsystem, such that they can be reused multiple times across these systems. A logging or exception handling component are classic examples. Reusing others' code means using community or third-party components. Telerik, for example, provides a library for reusable controls. The following link explains 2 important design principles, cohesion and coupling.
The URL reads http://msdn.microsoft.com/en-us/magazine/cc947917.aspx.
While Code Complete, a practical handbook of software construction, is a great resource for software construction best practices. And Course Clean Code, Writing Code for Humans, explains how to write human-readable code.
The video ends.